Hello everyone, welcome to my session on a tour of Matplotlib. I'll be taking you through several slides, several graph plots made with Matplotlib. I'll start with some simple charts like line charts and bar charts, and then move on to fun stuff like XK series teleplots. Along the way, I'll also share a couple of stories where Matplotlib made a difference in my personal life and professional life. Before we get started, let me introduce myself. I am Susam Pal. I am a security architect at Walmart Labs. I develop services in Go and Python. In my free time, I also work on a couple of my open source projects. Those are the links to my open source projects on GitHub. And I've specified the links to my Twitter profile, GitHub profile, and my blog. Once this talk is over, I'll be sharing the slide deck on my Twitter in case you want to take a look at it. So let's get started with Matplotlib now. Matplotlib, as you might be aware, is an extremely popular plotting library in Python. It can be installed using the pip command. I usually create a virtual Python environment and then install the library in the virtual Python environment. Once it is installed, it is quite easy to test it out. Just launch the Python interpreter, import matplotlib.pyplot as PLT. That's just a very popular convention that is used in the Matplotlib community. Then call the plot function, give it a list of numbers to plot, and finally call the show function. As soon as you execute the show function, something like this should pop up on your desktop, and this shows that Matplotlib is working fine. In this particular plot, it's one dimensional list that I've given, which is unusual. Usually we plot two-dimensional plots or three-dimensional plots and so on. In this, what Matplotlib has done has taken this bunch of numbers and plotted them against their indices. For example, this 2 is at index 0, so if you look at x equal to 0, you have y equal to 2. So we'll stick with this plot for a while. One theme I'll be following in this presentation is take a plot and keep customizing it until it looks good. For example, the first thing I want to do is save this plot as an image file. And saving a plot as an image file allows us to use this file in, say, web articles or blog posts or documentation. The way we save a plot to a file is using the savefig function call. We specify the file name as an argument. We need to be careful about the DPI setting though, dots per inch. By default, Matplotlib uses a DPI of 100 dots per inch, and 100 DPI is not too bad, but it is not great either. To show you what I mean, I'll take this tick label 2 that you see along the y-axis and blow it up on the next slide and show you what it looks like under different DPI settings. So if you look at 100 DPI, the 2 is quite blurred, right? It does look blurred. With a DPI of 300, it's much smoother. And as you increase the DPI, the plot keeps getting smoother and smoother, although the file size increases. So in practice, I found that with a DPI of 300, you get a good compromise between the file size and the quality. So I usually go for a DPI of 300 when I'm saving plots to image files. To save a plot with a DPI of 300, we need to use this additional keyword argument called DPI with a value of 300 while calling the savefig function call. Apart from customizing the DPI, another thing I like to customize is the default bounding box. So if you see this bounding box, it is quite large compared to the actual area covered by the plot. This could be a problem if you're trying to share a plot like this in a web page where there are a lot of text paragraphs, for example. Because if you know HTML and CSS, you will know that each text paragraph introduces its own margin above and below itself. And if there's a lot of padding around an image like this, that creates a lot of vertical space in the web page when you put an image like this between text paragraphs. So to get rid of this additional white space, I like to compute a title bounding box so that most of this white space is gone and it is more suitable to be included in a web page which has text paragraphs. I do that using the bbox_inches keyword argument with a value of type. This computes a much tighter bounding box like this. Okay, so we'll stick with this plot for a while. We'll keep improving this. In this slide, I'm using the X label and Y label function calls to specify the labels along the X axis and Y axis. Yeah. So now I want to make each number that I have shown on this plot in a more prominent way by using circle markers. The way we do it is using this extra argument called the format string. This format string has two letters, O and hyphen. The O stands for the circle markers. So now you see each numbers are visible quite prominently using the circle markers. The hyphen is for the solid line. The solid line was default anyway, but if you're going to override the default setting and try to customize it ourselves, we need to put this hyphen back if you want to see the solid line. If you just put the letter O, we'll only see circle markers. The solid line will not appear. So since I want both of them, I've got O followed by hyphen. And now I'm trying to get rid of the fractional tick labels. I'll show you the previous slide once more. So if you see this, there are fractional tick labels here, which is not useful in this particular plot because this is a plot of numbers versus their indices. So if I want to get rid of these, I can make use of this xticks and yticks function calls. I call xticks with a list of 5 integers, 0, 1, 2, 3, and 4, and that's what we see appearing on the x-axis. And similarly for the y-axis with the yticks function call. Let me spend a little time with the format string. So we saw this format string here, O hyphen. So what does it look like? The syntax is composed of 3 parts, the marker shape, the line style, and the color. Okay, so let us see an example. There is O hyphen K, that's an example where O stands for the circle marker, hyphen for solid line, K for black color. And there are many other color abbreviations supported. For example, R for red, G for green, and so on. And colors itself is a huge topic, which I will not be covering in this particular presentation. But there are many different ways to specify colors in Matplotlib. This is one of the simplest ones that I'm showing you on the slide. And of course, we have seen how to use the format string in a previous slide. Let me show you a few more marker shapes. If we use dot as a format string, it shows us point markers. O for circle marker, we have seen this already. Lowercase b for triangle down marker. S for square marker. And this is the whole reference of markers to choose from. I think there are 25 of them on this particular screenshot. There are only 4 line styles, so I'll show you all 4 of them. Hyphen for solid line, we have seen this already. Double hyphen for dashed line. Hyphen and dot for dash dot line style. And colon for dotted line style. This is the reference for all 4 line styles. Okay, so now let us move on to a new type of plot. This is a bar chart. It's in this bar chart I'm trying to show the number of tigers in 4 Indian states. It's really simple to draw bar charts using Matplotlib. So we have this bar function call here. We specify these categorical values as the x-axis coordinates and the list of the height of each bar as the y-axis coordinates. And once we make this function call, we get an output like this. Now I'll try to improve this plot a little bit. One thing I want to show is a legend here, which will tell us that this is these bar charts represent the number of tigers. So to do that, we need to make 2 function calls. So this is the legend that I was going for. the first thing we need to do is specify a label like this while using our plotting function, and then we need to call the legend function call. So this legend function call picks all the labels that have been defined for various plots and puts them together into a legend box like this. Okay, so let me improve this further. The next thing I want to show is the number of tigers on each bar column here. For example, if I were to look at this graph on its own, I should be able to tell that there are 529 tigers in Karnataka, 190 tigers in Kerala, and so on. So how do we put those numbers on these bar columns? So to do that, we'll use this function called text. So this text function called from the PyPlot module can take any arbitrary text and put it at arbitrary locations on the plot. So we need to tell what to write on the plot, and we need to give it the x and y coordinates to place it at a specific position. So how do we find this x and y coordinates for these numbers to be placed in this plot? In case of bar charts, quite conveniently, these bars are situated at integer coordinates along the x-axis. For example, this first bar is placed at x equal to 0, and the second bar is placed at x equal to 1, and so on. We can modify this if you want to, but that's the default behavior, and we'll just rely on that behavior to put these numbers at the right place. For example, we want to pick this 529 and put it here, so we'll ask the text function call to place this 529 at x equal to 0 and y equal to 529, which is the height of this bar. And this for loop here is doing the same thing for all 4 numbers in this tigers list. There are 2 problems though, which you might have already noticed. These numbers are sticking to the bar columns, and they are not exactly centered on this bar. So can we fix that? So let me explain why this is not centered. So we have been giving it x and y coordinates to put these numbers at specific places. These numbers are, these text snippets are left aligned with respect to that coordinate. So if we can tell it to somehow center align it, that would fix the centering problem. So we'll fix both those problems, the sticking with the bar and the centering problem in this slide. So you're creating more room from between the numbers and the bar columns by adding another 5 to each y coordinate value, and we're using this keyword argument called HA, which stands for horizontal alignment, equal to center, to center them. So when we talk about bars, we can make group bar charts like this, where I'm showing the number of elephants along with the number of tigers, and we can also make stack bar charts like this, where the number of elephants is on top of the bars for elephants are on top of the bars for tigers. The code is a little bit more verbose, so I'll not be describing it right now. It's in the slide, and I'll be sharing the slide on Twitter later. So for now, let me move on to the next topic. So this is a personal story. About 6 years ago, when I was dating my girlfriend, on Valentine's Day, I thought I'll make a mathematical Valentine. So these are the 2 equations. This is how I'll start. I'll not explain these 2 equations right now. It'll take some time. So I've got a GitHub link there which has more details about the 2 equations. So let me just start with these 2 equations. Just take my word for it that if we plot this, it will result in a heart-shaped curve on a 2-dimensional Euclidean plane. So in this slide, I'm just taking those 2 equations and converting it into Python code. These 3 lines represent the 2 equations in the previous slide. So the x value is set to a huge number of values between -1 and 1, and then I'm computing the y coordinates for each of those x values using the 2 equations that were present in the previous slide. You might see the 2 equations written in LaTeX form once again here. That's because I want to show a legend like this, and that's one of the nice things about Matplotlib. It supports LaTeX in a variety of contexts like title, X labels, Y labels, as well as legends. So that's why I have this LaTeX code here, and I specify this LaTeX code as the label argument here, and then I call the legend function call to show the legend. You might have noticed a problem here already, that is the legend is at an awkward position at the center of this image when we are usually used to seeing it somewhere at the top right corner. So that's because there's not much room around this heart to put a legend at a good place. In this particular case, when we call the legend function, it tries to figure out what is the best place to put the legend, and it has found this as one of the places. We'll fix this problem by creating more room around the heart, and to do that we'll call the xlim and ylim function calls. So the xlim function, with the xlim function call, I'm increasing the x limits from -1.5 to 1.5, and likewise for the y axis limits. Now there is more room around this heart, and as a result we have the legend at the right place. So when I was doing this 6 years ago, the look and feel that I was going for was the graph paper look and feel. The kind of graph paper that we used to use in our high school days, with the green color grid. So I hope you get the idea. To get that look and feel, we need to plot a grid on this plot. And to plot a grid, we need to define the major tick locations and the minor tick locations. So we'll do that now. So these 5 statements define the major tick and minor tick locations. This GCA call, this means get current axis. This gets the current axis for the plot, and then we get hold of its x-axis and y-axis, and we start defining the major and minor tick locations. So this first statement, for example, is telling that every multiple of 0.5 on this x-axis is a major tick location. The second line here is saying that every multiple of 0.1 is minor tick location, and likewise for y-axis. So once these tick locations are defined, it's really easy to plot a grid. We only need to call the grid function calls like this, once for major grid lines, once again for minor grid lines, and specifying the color to green, and I'm making sure that the major grid lines are thicker than the minor grid lines. Next, I want to make the tick labels as well as tick lines also green in color. For that, I'll be using the tick underscore params function call, and once again I'm calling it twice, once for major tick params, once again for minor tick params. I'm coloring them green, so I've got something like this. The next thing I want to fix is these bounding lines. The 4 bounding lines that you see here, they're still black in color. I want to make them as well green. Alright, so there's one more thing I want to cover before that. So if you see in this tick lines, they're protruding outside the bounding boxes. So that doesn't look very pretty, so I want to get rid of those so that this plot looks much more cleaner and crisp. So in order to do that, I'm setting the tick length to 0, and that gets rid of all this protruding tick lines. Now I'll fix the bounding lines color problem, which is still black. I want them to be green. So these bounding lines are called splines in Matplotlib. So we'll get hold of all the 4 splines using the axis object, and I'm setting them all of them to green. And that's how I have got very close to the graph paper look and feel. There's one little problem, and that is these grid boxes. So these grid boxes, each major grid boxes is 0.5 by 0.5 in dimension. Although it doesn't look like exactly like a square, it looks a little bit squished. That is because of the aspect ratio. So now I'm setting the aspect ratio to equal, so that the same scaling is used for plotting both the x-axis and y-axis units. And now the grid boxes look like square. As a result, the heart also looks more wholesome now. Finally, we can put some personalized message like this, and we use the text function call again. We saw the text function calls while putting numbers on top of those bar columns in the bar chart. So it's the same function call. We give it the x and y coordinates and the message we want to put. So of course, when I did this for my girlfriend 6 years back, I put my own personalized message, and I printed this on a good quality paper, laminated it with a lamination sheet, and presented it to her during the dinner. She was impressed. She liked what she saw, and and now we are happily married, so I can so I can tell you that this thing worked out pretty well for me. All right, so let me now move on to a professional story. So this is a line chart. It's showing a performance problem in a log parsing engine that I was working on several years ago. This is telling us that it takes 1 second to process a log file containing 1000 logs, 3 seconds if there are 2000 logs, and close to 520 seconds when there is close to 8000 logs. So the problem here is that the time consumed to process this log file is not growing linearly with respect to the number of lines of log. If it were, it would have taken only 8 seconds to process this 8000 lines of log, when it is taking just 1 second to process 1000 lines of log. So my responsibility was to run a bunch of experiments, understand the numbers, and present it to our management, because this was a problem that was affecting our customers. So when I decided to present these numbers, of course I thought I would plot it using matplotlib like this, but then I thought, in order to lighten the mood of the conversation, maybe I'll not present it in just this format, but something like this in XKCD style. So, so you can see those little wiggles, and most people I've seen in the technology industry love XKCD, so once you put something like this, it starts its own conversation about your favorite XKCD comic. So it's really easy to plot something using the XKCD style. We just need to make this one single function call here, and once this function call is done, all plotting functions start using the XKCD style plotting mode. This font here is called the Humor Sans font. If it is installed on your system, it will be automatically picked up for any XKCD style plotting. This is recommended by the matplotlib documentation itself. And yeah, so this is the Humor Sans font. There's one little trick to be aware of though. Once you install the font, you have to remove any matplotlib cache directory that might be present in your home directory. So I've got the commands here for both macOS and Debian-based systems. That is because only if you remove the cache, it will be forced to rebuild the cache when it runs the next time, and rebuild the font list and find this new font that is on your system. There are a couple of ways to customize an XKCD style plot. These are the 3 keyword arguments it takes: scale, length, and randomness. Scale stands for the amplitude of each wiggle, length is the length of each wiggle, and randomness is the randomness in the length of each wiggle. So I'll give you some examples. So scale, mind you, is the amplitude. So when I increase the scale to 5, the wiggles are a little bit more prominent. I'm not sure whether you're able to see that from back there. If the scale is 0.2, which I've reduced the scale, the wiggles are so subtle that they almost look like straight lines now. This is the wiggle length. If we make the length as, so here I've decreased the length. The default was 100, so I've decreased it to 20, so the wiggles are shorter. But if I increase it to something like 500, the wiggles are so long that they again look like straight lines. Finally, the randomness. To make the randomness apparent, I have increased the scale as well, so that you can see the wiggles more prominently. So with a randomness of 1, the wiggles look very regular. There doesn't appear to be much randomness. But if we increase the randomness to 10, they are more irregular now compared to the one in the previous slide. Yeah, so that was all. That's all I wanted to share with you.
Okay, thank you very much to you, Susan. We probably have time for a quick question. One single question. Does anyone have any questions? Down here at the front, please.
So the problem that I have with PyPlots is that the plotting libraries in Python in general is that approach that everything happens in the global context.
Yes.
And like you just mentioned, if you make changes to the style of your one particular plot, it affects all the other plots created after that. So I'm just wondering what's the reason behind it, why all of these developers are taking this apparently strange approach. It is something that I'm missing.
Yes.
How is it helpful? Because it seems to be very unhelpful.
Yeah, I think the answer is the heritage of the software which is inspired by MATLAB, and MATLAB have taken that approach of picking, having all the settings in the global context. Although Matplotlib gives us final control. For example, the GCA function call or the GCA function call, they help us extract only the current figure or the current axis, manipulate them without affecting anything else. And similarly, there's the SC, I think, which is the set current axis and SCF set current figure. So it is possible in Matplotlib to make changes to a local context and then give it back to PyPlot. So that is one of the ways to work around that problem.
Right. Thanks.
Okay, thank you very much. Another round of applause.